We'll now be going over examples for the lesson on arithmetic sequences. We'll start by determining, for numbers 1 through 4, whether this sequence is an arithmetic sequence or not. So let's start with 1. The character of an arithmetic sequence is that there is a common difference between adjacent numbers. So if I start by taking 21 minus 28, I get negative 7. The same should apply if I do 21 minus 14. And that's true, it's negative 7. And if I do 14 minus 7, 7 minus 14, I get negative 7. Therefore, this is an arithmetic sequence with the difference of negative 7. For number 2, I can take the difference again. 13 minus negative 10 is 23. 36 minus 13 is 23. 59 minus 36 is 23. So this is an arithmetic sequence where the difference is 23. Now for number 3, let's try this again. Negative 1.7 minus 3.2 is 1.5. Negative 0.2 minus negative 1.7 is 1.5. And 1.3 minus negative 0.2 is 1.5. So this is an arithmetic sequence where the difference is 1.5. And for number 4, we have 3 halves minus 7 halves, which is going to be negative 4 halves, or negative 2. Then 5 halves minus 3 halves, which would be 2 halves, or 1. We immediately see these do not match up. Therefore, this is not an arithmetic sequence. Now let's try finding the following 3 terms in each of these arithmetic sequences. So let's start with number 1. To continue this on, I have to take this number, this last one they've written down, and I have to add that with the difference. So 7 plus negative 7 is 0. 0 plus negative 7 is negative 7, and negative 7 plus negative 7 is negative 14. Now for number 2, with the difference of 23, I take 59 and I add 23. So 59 plus 23 is 82. 82 plus 23 is 105. And 105 plus 23 is 128. For number 3, the difference is 1.5. So I take 1.3 and I add 1.5, which is 2.8. 2.8 and I add 1.5, which is 4.3. And 4.3 plus 1.5 is 5.8. For number 5, we need to write an equation for the nth term of the arithmetic sequence and graph the first 5 terms of the sequence. So to start off with, we need to recognize the common difference. And this is just the same as number 1. We know d is negative 7. The equation for the nth term, if you recall, is a sub n is equal to a sub 1 plus d times n minus 1. So in this case, a sub n is equal to 28 minus 7 times n minus 1. And this can be simplified to negative 7n plus 35. So now we need the 5th term, as the question asks, which is 0. And we graph it. The axes are n and a sub n. So now I've chosen a scale, and we just plot the points. So when n is equal to 1, the first term is 28. And when n is 2, we have 21. And when n is 3, we have 14. When n is 4, we have 7. And when n is 5, we have 0. So we can now draw those dots And if we choose connect the line, and we can see the arithmetic sequence graphically.